Alright, so this is 1.2. If you have any questions on the homework in 1.2, this is the right video to be watching. Okay, we're going to start with questions 15 and 16, or that style of question rather. Okay, question 15 and 16 says, sketching the graph of an equation, and the questions I've given you for homework are just lines. So it's graphing lines based on some kind of grid of numbers. So you just figure out what x is. And this is nice because it tells you. It'll say, you know, take x is minus 1, 0, 1, 2. It will give you various values. Just try. And then what happens is, I'm going to give you a different, let's say this isn't your homework, but maybe it's something like that, right? So you just put in x is -1, and then you get 7 minus 2 is 5, so you put a 5 there. If x is 0, y is 7. If x is 1, you get 9, and so on and so forth. And then what you do is you just plot these points, -1, 5, 0, 7, 1, 9, 2, 11. And then you just sketch a line. Okay, so you put these labels on here. You'd put like a 5 here or something. Okay, so that's the way those kind of problems work. It's just line graphing, light and easy. Alright, so what about the next type of question? 23 through 25. This is finding the x and y intercepts. So I'll use a different question that's not in your homework, but for example, number 28, x and y intercepts questions go like this. You just try x equals 0 to find the y-intercepts and y equals 0 to find the x-intercepts. If x equals 0, you get y is equal to negative absolute value of 10, which is -10. They're trying to trick you into saying 10, but it's actually -10. And so this point is 0, -10. And what happens if y is 0? Well, guess what? 0 is -0, so that just means x plus 10 still is equal to 0. So x is equal to -10. And so this point is -10, 0. So here is your x-intercept, and here is your y-intercept. So that's the process you would use to answer those questions. For number 25, it involves a square root, so at some point you square both sides. And I think you guys were fine with this in class, so I'm not going to belabor this. Okay, so what was the next type of question? 30 to 32 should be a different question type. Oh, they're really the same. The only thing you need to know is if x to the 4th minus 25 equals 0, you can factor this into x squared plus 5, x squared minus 5, and then this guy can split up further. This is x minus square root of 5, x plus square root of 5. So these guys are the roots we're concerned about. X can equal to square root of 5, or x is equal to minus square root of 5. That's your little hint. Okay, so other than that, I think you should be able to get through that question, those questions. 36 through 38, I told you you guys could skip. But since I'm making a video, I'll go ahead and answer that for you. So this is optional questions, 36 through 38. And it says use the algebraic test to test for symmetry. So the symmetry tests, okay, the symmetry test is you try replacing minus x, try replacing x with minus x, or try replacing y with minus y. And then what you do is there's two options that can happen. You can determine that when you replace x becomes minus x, you can either have one of two things happen. Nothing happens and you get a symmetry, or you can get a flip where all the signs flip. All signs flip. And the same scenario happens with y. When you replace y with negative y, either nothing happens or you get a flip. Okay? And in that case, there's just 4 possible outcomes, and let's talk about that. So if you have a situation where you have this kind of symmetry, okay, if you have a symmetry this way, okay, symmetry about y-axis, then what you're going to do is you're noticing that whether you're on x or negative x is the same. F of x equals f of minus x. So replacing x with negative x does nothing to the function. You just get a whole bunch of negatives that cancel each other out. However, if you have this situation, right, if you have this kind of symmetry, this kind of thing, then what happens is if you're here at x and compare against negative x, everything flips. So f of negative x is the same as negative f of x. Then that's the other kind of symmetry. This means you're symmetric about the origin. And that's the same phenomenon you will see if you say, I replace y with negative y, so I replace x with negative x, or y with negative y, and you get a flip happening. Flip about origin. So that's the other situation, but there's 2 ways to find that situation. All right, and then finally, we have this other situation, which we very rarely worry about, but I could say x equals y squared, right? And then if I replace y with negative y, in this case nothing happens to the function, then I know I have this kind of symmetry about the x-axis. Okay, so that's all that explanation. Now I can show you how to do the problems, but let's see. Since they're optional, I can do the actual problems. So number 36 says y equals x to the 4th minus x squared plus 3. And so all that explanation you can do very quickly. You can just say, hey, I can see that if I replace x with negative x, nothing happens. I don't even have to do anything because I see it's all even exponents. So we know this function has symmetry about the y-axis. And you don't have to plot it, but if you want to, you can go to Wolfram Alpha. But that's the kind of thing that this kind of test is good for. The same thing applies to number 38, this function y equals 1 over x squared plus 1. And you don't even have to know what the function looks like. You just know that it has the same kind of symmetry. Okay, so then there's one more question. The last question is y equals x over x squared plus 1. So it's taking advantage of the fact that, you know, when you replace x with negative x, nothing happens in the denominator, but you get a flip on the top. So this is a flip situation. So you have symmetry about the origin. And the way you do the algebra is you'd try y is equal, y of, you'd write it this way, y of minus x is minus x over minus x squared plus 1, which is minus x over x squared plus 1, which is minus y of x. So when you replace, so this is the thing you're trying to show, that y of minus x is minus y of x. That means we got to flip. Okay, again, that was all optional, so I'm going to erase this and go on from there. Okay, number 70 through 72. And it says write the equation of the circle. So I'll just pick a different question, like number 73. So if the center is minus 1, center of the circle, and yeah, I'm going to make up a different one. This isn't even in the book. Okay, point on circle. Okay, so there's the center, there's the point on the circle, and they want to know, actually the questions you're doing are different. Yours is center radius. I'm not even going to do this one. I'm sorry, because I don't want to lead you astray. So I'm going to just give you one that's similar to yours. Center can be 7, 3, radius can be 13, and I just made that up. So how do you do that? You just say x minus, we usually call this guy h and this guy k. I have no idea why that's h and k, but that's what we do. And then you say y minus k squared. So that value goes here, that value goes here, and that value goes here. We call this one r. So that's just the answer they're looking for. It's not very fancy. Okay, so they're all identical. You just pop in the center pieces. And I guess the only thing people sometimes mess up is this is a minus, not a plus. And that's basically the only error I've seen people make on this type of question. All right, so I guess that's the end of section 1.2.